Hello guys, welcome back to Maths on African Motives. We are still on our mathematics for grade 10, working with the inequalities. In this class, we shall actually have an introduction, just like the other classes that we had. We just want to talk about these inequalities. What is it that you are referring? Actually, we talked about this from our mathematics grade 9, so it's just a continuation that you just need to recall on inequalities, the difference that we have in terms of our inequalities from an equation, because most of us, we confuse this with equations, all right? An equation. When you are referring to an equation, you are referring to a condition whereby the left-hand side, all right, the left-hand side must be equal to the right-hand side, okay? What you have on the left is equal to what you have on the right. Like I can write this, maybe x plus 3 is equal to 7. I'm saying what I have here should be equal to what I have on the other side. That's an equation. An inequality, we are no longer having this equal. They cannot be equal. It's either they can be great or less. The equal can be there, but greater than and less than must be there also. Not just a direct equal sign like this. So that's what we're going to have on our inequalities. On our inequalities, we are having the same thing as an equation. We need to solve for x. Also there, we need to solve for x. But an inequality now, you shall have something like this. That's an inequality. You will be given x plus 3 like this. It can be greater than a certain number, which is 7. It can be less than. It can be greater than. So we need to know the inequality signs, which is the language that we use in our inequalities, and how do we apply this language of the inequalities. In a normal sense, the inequality sign, we cannot say this one is a greater than, this one is a less than. Okay, let me explain this way. If I write in this way, okay, I want to compare two sides, okay? I want to compare two sides, the left-hand side and the right-hand side. So the sign, the same sign that we have here, which we refer this as a greater than sign. But like I said, it depends because of the side that you are referring from which side, okay? From which side, okay? If I move from x going this way, it means x is greater than a. X is the one that is pointing a, okay? X, you don't point an elder, we know that. An elder can point you, but you can't point an elder. So this x is pointing a, so it means a is small. X is the elder, a is the younger one. The one that is pointed is the smaller one. So x is bigger than a, greater than a, okay? But now let's talk about the one that was pointed, which is a. How can we refer a going back to x? What can we say? We said x is greater than, all right? Greater than a or bigger than. So it can be bigger than a. It can be larger than, okay? It can be bigger than, we know that. I just want you to know, this is not the major part of your level. Your level is to solve, but I want you to just know your basics from your grade 9 so that we'll be able to move together actually. Okay, like I said, I want us to also refer back to a, back to x from a. So from a going to a, we are saying a is smaller because remember a is the pointed one. Like I said, you can't point your elder. The one that is being pointed is the younger one. So A being the one that is pointed, as you can see, this is pointing to what? To A. So it means A is less than, okay? A is less than what? is less than x. A is smaller than. All right? Smaller than, lesser than. Okay? We are now comparing two things there. So we're going to have a lesser. So it's less, this one is bigger or greater from x. From A is smaller than x because A is pointed. So like I said, it's how we read the inequality sign from which side. So let's take two numbers now. We know two numbers. -1 is definitely, maybe compare this to 3 or to a 5 or to a 7. We're going to say -1 is less than a 7, right? -1 compared to 7 is smaller than. 7 is pointing to 1. So it means 7 is bigger than 1 or 7 is larger than 1. Okay? But reading from 1, -1 going to 7, we are saying -1 is less than a 7. You see? -1 is less than a 7 because it's the one that is being pointed. But if we take it from this side, going to -1, 7 is pointing -1, so 7 is bigger than this. Okay? So we need to understand how to operate with these inequalities. Just like I said, they operate the same way as equations. The only difference, or some of the things we shall see them, we are going to notice on our solving of equations. I will talk about that as we are solving equations, but we are going to see that whenever we are working with equations, you are not change the direction of the inequality sign whenever you multiply or divide by a negative. That is the only part that can make an inequality to differ from an equation. I shall explain that one on our examples. We can only change the direction of the inequality sign whenever you multiply or divide by what? By a negative number. The inequality sign, it reverses or it changes its direction. But this cannot affect or cannot change if we multiply by a positive. You do not change anything, okay? So on that case, if you multiply by a positive number, you are not going to change anything. And if you transfer like a number to another term or subtract or add, you also do not change anything about the inequality sign. It is only changed by multiplication and division by a negative number. That's the only thing that can change the direction of an inequality. Okay, let me explain this way. Let's say I'm given a condition. Okay, remember, I'm going to give you two different things. 2x plus 1 is equal to 2. This is an equation, okay? 2x plus 1 is greater than 2. It's an inequality. So this one, it's an equation. So I want you to be careful. This one is an equation. There's an equal to. This one is an inequality. All right? So on an equation, I transfer this one to the other side of the equation. Here it becomes a -1. Remember how you solve your equations, guys. We talked about this from our linear equations. So we are going to have 2x is equal to 2 minus 1. Okay? 2x is equal to 2 minus 1, which is a 1. We divide by 2. We divide by 2. This is going to give us x is equal to 1 over 2. It's an equation. We are maintaining equal, 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 equal throughout. Because of what? An equation. They are equal. Inequality, they are not equal. It can be greater than or less than or greater than or equal to, but the greater and less must be there. So you solve the same way. If you transfer this number here, just like our equation here, we have to transfer this one to the other side of the equation, but this time to the other side of the inequality. So it does not affect anything. That's what I'm trying to say. Changing this to the other side of the inequality, it does not change anything. Okay, so this will be 2x is greater than a 1, 2 minus 1, that's a 1. We divide by 2, we divide by 2. Also, it does not change anything because we are dividing by a positive. The inequality sign is going to remain as it is throughout. The inequality sign is going to remain as it is. You do not change anything. But let's say with this condition like this, okay? I wanted us to see the difference between the two again, from an equation to an inequality. I want us to see the difference now. If we put a negative here, we put a negative there. All right. On an equation, we're going to solve, okay? We transpose just like the previous case. This one, it goes this side. We're going to remain with minus 2x is equal to 2 minus 1, which gave us a 1. Minus 2 is equal to 2 minus 1, which is a 1. We divide by negative 2. By negative 2, both sides like this. X will be equal. We just take our negative on top, just write as minus 1 over 2. Because it is an equation, there is nothing that is going to be affected. I'm not going to change anything. There's no equal sign being changed to another sign, something like that, because it's an equation. But for an inequality now, let us take an inequality. Minus 2x, we transpose this as an equation. Transposing, adding or subtracting, I say this one does not change your sign. So it's going to be 2 minus 1. The sign is not even affected. So it's minus 2x is greater than 1. We subtract 2 minus 1. The moment now that we want to find our x, which is being affected by a negative 2, this one, we are supposed to divide by a negative 2, by a negative 2. This is an inequality. That is the difference. You are dealing with an inequality. So what happens is that the sign reverses this one. Let me indicate it here. This sign, it is going to change. You change that sign. Okay, so let me write it here. It changes the moment you divide by what? By a negative. Or the moment you multiply by a negative. So that means in this case, our x, this sign is going to change. It will reverse. It points in this direction now. So it will be minus 1 over 2 like this. Okay, sorry for that. So that will be minus 1 over a 2 like this. So that is the difference that we have between an equation and an inequality. Okay, the multiplication by a negative or the division by a negative changes the inequality sign. It reverses its direction. It changes the direction. Everything that you used to know about your equations is not going to change. What is it that I'm talking about? Expanding of brackets, if they are brackets, okay? Clearing of fractions, if they are fractions, all right? All those things, they're not going to change. We're gonna talk about if they are fractions, we have to clear the fractions, right? We have to clear our fractions. In that case, how do you clear the fractions? By multiplying by the LCD, by multiplying. So you're gonna multiply, multiplying by the LCD, which is our lowest common denominator, or the LCM. That is how you clear your fractions. All that part is not going to change. Maybe cross multiply, it's one and the same thing. All right. We talk about brackets, clear brackets. If there are brackets, we have to clear them. We are now talking about the distributive rule, whereby you have to distribute everything by what is outside of the bracket, collecting of like terms. All that part is not going to change. The only thing that changes is when you go to division or multiplication by a negative sign. The inequality sign is going to change. So let us see our questions here. We are given questions. Solve the following inequalities and then represent their solutions on a number line. Remember, we talked about a number line from our mathematics grade 9, from maths grade 9, whereby we saw a number line can represent the values of x. We shall talk about that one as we are indicating our solutions. But for the meantime, I want us to focus on the solving. So here we are given, solve the following inequalities and then represent their solutions on a number line. So the first inequality that we are given is states that 2x is greater than minus 6 like this, okay? 2x is greater than what? Minus 6. 2x is bigger than minus 6. We are reading from the side of 2x to this side. It is the one that is pointing, so it's greater than. Okay, that part does not affect, because here we can simply divide, since we are multiplying, we can simply divide by 2. But what are we dividing with? We are dividing with a positive number. So to divide with a positive number does not affect your inequality sign. The inequality sign remains as it is. So this will be 2 into this, which is -3. The only thing that can affect your inequality sign is when you divide or multiply by what? By a negative number, okay? So what are we going to have at the end, okay? Very sorry here, my board has shifted a little bit. So remember your number line. Now I'm going to explain about the number line on this one. A number line, it is one that shows us where the values of x are being taken, okay? Remember like this. Let us say this is at 0 here. These are the points. We're going to have 1, we're going to have 2, we're going to have 3, we're going to have 4, and so on and so on. All right. The same thing on this side. We're going to have -1, -2, -3, -4, and so on and so on and so on. These are the values that represent x. But we want a condition where we have x being at -3. So at -3 it's here. So you indicate with a circle there. All right, you are going to see that if you have a greater than or equal to like this, you are going to shade the circle if it was a condition that your sign is greater than or equal to, or it's a less than or equal to, depending with the side that you're talking from. You shade the circle. For a greater than or for just a less than, you just draw a circle that is not shaded inside. Then you indicate the direction by the arrow. Okay, this is a number line. So you indicate your direction by the arrow to say which values are we talking about which are greater than -3. Greater than -3 means bigger than -3. Are we going this side or are we going this side? We have to compare. As we are going this side, -2, -1, 0, 1, 2, 3, 4. These values compared to -3, what are they to -3? -2 compared to -3. -1 compared to is -1 bigger than -3? Yes, it's bigger than. Is 1 bigger than -3? Yes, we said being closer to 0 when you're talking about negative means bigger. As long as a number is a positive, it's bigger than what? A negative number. As long a number is a positive, so it means all these positive values, they are bigger than -3. So the answer that you want is going to be taken this direction. So you just indicate that direction with what? With an arrow. There are so many, it's up to infinity. They do not end. Values that are bigger than -3, they do not end. 1,000 is bigger than 3. 1 million is bigger than 3. They do not end. So you indicate with an arrow to show that your values are up to infinity. They do not end. So that's how you can represent your number line. Okay, so that was it for this one. It was just a direct question. Like I said, we just have to go back to our equations, refer to our equations. So this is the same case that we have on the B part. On the B, we are now given this as -2x is greater than -6. So take note on this one, we are supposed to divide by a -2 by a -2. But take note of what I said. The moment you divide by a negative like this, what happens? The inequality sign, it is going to reverse. This sign here, it is going to reverse. So meaning to say we are going to have x is now less than. It will point the other way. It reverses, it changes the direction. All right, we cancel this or we divide on our calculator, we get a 3. So we are saying we need a condition on a number line now, the condition that we consider. So you saw that there is no need for you to even write all those values. What is important on your number line is to indicate where we find a 0 and where we find that number 3. Is it on the left or on the right? It's a positive, so it's found on the right on this side, we can find -3, not +3. Okay, so you just indicate the side, the number that you want in this, that you're given in this view. Then you compare now to say, if I am to put, okay, the inequality there is less than, so I'm not gonna shade, I'm just gonna represent with a circle like this. So I ask myself, which values am I going to take? Which are less than, x must be less than these values that we are talking about here. They are supposed to be less than 3. So are we going to the left or we are going to the right? So we are going back. Remember, these values, there's 3, 2, 1, and so forth. Yes, there's 4, 5. So values that are smaller than 3 are these ones, 2, 1, 0, and so on and so on and so on. These are the values that we want. So we indicate those values with what? With an arrow. So you're just going to indicate those values with an arrow, showing that they are going this direction, okay? The circle, you do not shade because it's a less than sign. I said you only shade when it is less than or equal to, maybe, or greater than or equal. When there is this equal to, when the equal to is there, you shade that part. It means the value is also included in the solution. You need that on your answer. Okay, so that's it, guys. Then C is the one and the same thing. On C, we're gonna see that just said to expand our brackets, like I said, the same application, just like our linear equations. Remember, from our linear equations, we had equations that had what? That had brackets. So here I've got brackets. So we're gonna consider clearing of the brackets. 4 into 2x of -1 is greater than 5 of x plus 2, like that. So what you have in this case is that you're supposed to clear brackets so that you can be able to collect your like terms, still following the concept, okay? Brackets, distribute everything by what? By 4 here. So we're going to multiply by 4 into everything. So that's 4 times 2, which is going to be 8x. 4 times -1, which is -4, is greater than 5x plus 2. So at this case, just like an equation, we said taking these, transposing this, and that does not affect. So if I take my 5x this side, and if I take my -4 this side, this does not affect. It does not affect. So it remains as it is, our inequality sign, okay? So, but the numbers, they change. We know that once you cross, it's going to be a negative. So it's going to be 8x, 5x to this side, it becomes -5x, all right, is greater than -4 goes that side, it becomes a positive. Already here, there was 2 was a positive. So if we take this -4 this side, it becomes what? It becomes a positive. So this is what we have, 8x minus 5x, that will be 3x is greater than, we add, this will be a 6, 2 plus 4, which is a 6. So what you simply need is to add these two, that's 2 plus 4, which is going to give us a 6. Then we can divide by 3 by 3. What are we dividing with is a positive number, so it does not affect our sign also, all right? It is only affected if you divide by what? By a negative. So if we divide 6 by 3, we are going to get what? A 2. So x is bigger than what? X is bigger than 2. So if x is bigger than 2, therefore it means we are going to have our number line like this, all right? So like I said, 0 is important. You can just indicate 0, then you indicate where there is 2, or just indicate where there's 2. It's still one and the same thing, okay? It's a greater than, so you're not going to shade, just going to draw a circle. But which values are we going to consider here that are greater than, that are bigger than 2? Are we going this side to the right, 2, 3, 4, 5, 6, and so on? Or are we going back 1, 0, -1, -2, -3? Where are we going? We are going that side to the right because they are bigger than, we are talking about 2, 3, these values, 2, 3, 4, 5, they are bigger than 2. So the arrow, it points where the values are found, okay? That is where you indicate your arrow, because we do not have boundaries. We shall talk about another one, which is called what? Which is called compound inequalities. We shall talk about compound inequalities. Compound inequalities, we shall see what's going to happen with those ones. So a little bit that we just need to talk about. We shall see that in our next class. Okay, let's see D in this case, okay? D, we are given 2x, it's a fraction. So like I said, guys, these, they do follow. up everything that we talked about in our equations, okay? So there we've got, on D, we've got 2x minus 1 over 3, which is greater than or equal to 2x plus 1, like this, okay? So I can choose to clear the fraction, okay? I can choose to clear the fractions. But how? How so? These are inequalities, guys. Let me explain this way. The way you expand your brackets or the way you expand your fraction is similar to that part that you deal with when you're dealing with what? With fractions, okay? When you're just dealing with normal, equations. But if you mind also, you can consider taking these terms one side of the inequality. This one it's up to you. You can consider taking this to one side of the inequality, or you can just do this way. This is same as we've got an over 1 here. So I'm just gonna multiply by a 3 here. I multiply by a 3. What am I, guys? This is what I need you to understand at this stage. Be careful at this stage. It's only that here it's a positive, so you do not see the effect. But you have to consider, what are you multiplying with? Is it a negative number or a positive? Because we said multiplying or dividing by a positive, it changes if we multiply or divide by a what? By a negative number. The inequality sign, it has to change the direction. But in this case, it's a positive. So that's why I'm saying it's something that you might not see because it's a positive. So you might, what is he saying there? Okay, no problem. So this, let's just cancel there. Gonna have 2x minus 1 is greater than or equal to 1 into 3, that's a 3. So 3 is just gonna multiply 2x plus 1. So that means we're gonna have 2x minus 1 is greater or equal to, expand your brackets, distribute by 3, which will be 6x by 3 here. 3 times 1, that will be a positive 3. Then we can get our x to one side of the inequality. This one goes that side. The minus 1 can go that side to the 3. So if 6 goes this side, where there's 2x, it's going to be 2x minus 6. It changes, like it was a positive, then it becomes a negative. But the inequality sign does not change anything. It is not affected by this, okay? You transfer the negative 1, it jumps the other side, it becomes a positive there. So it's going to be 3 plus 1. So let's subtract 2x minus 6x. This will be minus 4. So that's minus 4x is greater than or equal to. We add this, we get a 4. So what we are supposed to do, in actual sense, you are supposed to divide here. Okay, what are you going to do here is to divide. All right, so at this stage, you're just going to divide by a negative 4. But remember what we say, to divide by a negative, what's going to happen if you divide by a negative on the inequality sign? The inequality sign is going to reverse this one because we have multiplied by what? By a negative number. So it is now less than or equal to negative 1. If we divide this, we get a negative 1. So that is going to be your inequality. X is less than or equal to negative 1. So if we take a closer look on this one, we can see that there is a less than or equal to there. There is a less than or equal to. So meaning to say, on your number line, it is going to be affected. Our number line is going to be affected. Remember what I said about your number line? Let's say this is where we have a 0 here, and this is where we have a negative 1. We are going to shade this term because there's what? Less than or equal to. The equal is also there. So you shade your circle at negative 1. Then you ask yourself, which direction am I going to take? Which values are less than negative 1? Is it to the left or is it to the what? To the right. Values which are smaller than minus 1, they are found on the left side, okay? So they just point an arrow to show the direction of what your values, to say I'm going to the what? To the left side where there's minus 2, minus 3, minus 4, minus 5. All these values, they are smaller than minus 1. The equal to is at that point at minus 1. That is where we can take x also to be equal to minus 1. But the values that you compare with, you compare using the less than sign to say, where do we have values that are less than -1. So that's inequalities. That's your inequalities. So we have an exercise, but I want us to work with compound inequalities on another class. Then we have an exercise where we combine everything. These linear inequalities and also the compound inequality. The compound inequalities, they are also referred to as simultaneous inequalities, where we are dealing with the two inequality signs at the same time. Here we are just working with one inequality sign. So make sure that you watch that video that we shall talk about the compound. Then also the video on the last part where we shall talk about an exercise covering everything and also the question papers as we go on.